Dear students, so this is the second video I am going to post in the online classes. The last online class I have covered the different types of control systems. So coming to the last classification, that is open loop and closed loop control systems, I will be dealing in detail in today's video about open loop and closed loop control systems. So as you can see in the diagram, the open loop control system, as I have discussed also, a system in which output is dependent on the input, but the controlling action or input is totally independent of the output, or changes in output of the system is called as an open loop system. Okay, in the broad manner, as you can see, this is the diagram. So the input, we usually call it as the reference input. The reference input is given to the controller. The controller will adjust the signal and give a actuating signal or a manipulating signal represented by U. Then that is given to the process or plant. Process or plant is the system which needs to be controlled, and we get the controlled output. The simple block diagram of an open loop control system looks like this. So as you can see in this diagram, the reference input is the calibrated input. For example, you need a temperature of 24 degree centigrade in the room, as I have taken the example. So that 24 degrees centigrade, this input is calibrated for that, and that is given to the controller. The controller gives the signal in the form of heat or whatever to the process to get the temperature of 24 degree centigrade, and it is adjusted such that you will get a temperature of 24 degree centigrade. But this output is not measured and it is not compared with input every time. Okay, with suitable calibration, it is assumed that the temperature we get is 24 degree centigrade. This is the working of an open loop control system. Okay, this is the working of an open loop control system. Now coming to real-time applications of open loop control system. So the real-time applications means simple examples of open loop control system. The first example is the sprinkler used to water a lawn. The system is adjusted to water a given area by operating the water valve and observing the resulting pattern. When the pattern is considered satisfactory, the system is calibrated and no further valve adjustment is made. Okay, we don't make any further valve adjustment. Similarly, a stepper motor positioning system, the actual position in such system is usually not monitored. The motor controller commands the certain number of steps by the motor to drive the output to a previously determined location. Okay, so in the sprinkler used in the water lawn, the output is the sprinkling of water. There is no device to measure that and give the feedback to the valve. Okay, initially only it is calibrated, and that calibration is used to sprinkle the lawn. Then next example is automatic door opening and closing system. As you can see in malls and all, you will be having automatic glass door opening and closing system. In this system, photosensitive devices are used. When a person interrupts the light, a photo device generates actuating signal which opens the door for a specific time. When the person passes through the door, the light becomes continuous, closing the door. The opening and closing of the door is the output, which has nothing to do with inputs, hence an open loop control system. Okay, so the opening and closing of the door, it is when the light is cut, the photosensitive device light is cut, the door opens, and when the light is not cut, when the circuit is closed, the door closes. This is how it operates, and the output doesn't have any relation to the input. That is, every time it is not changing. Okay, that is another example of an open loop control system. Now, automatic toaster system. This I have discussed in the class also. In this system also, the quality of the toast depends on the time for which the toast is heated. So initially only by trial and error you have fixed that maybe in 3 minutes the toast comes out perfectly. So you have set the desired time here. Okay, you have set the desired time for the toast, that is the desired time, say 3 minutes. Then the power input is given. Then this is the relay or controller. Then heating or processing of the bread and actual toast. Then there is no automatic measurement device to see how much is the bread toasted and then give the feedback to the input. There is no such device, so it is an open loop control system. Similarly, traffic light controller. A traffic flow control system used on roads is also time dependent. As you can see, when we will be moving in the traffic, the red light, the green light and the yellow lights change depending on the timing they are set. Okay, that is, the driver driving the car or the other vehicle should understand that after 120 seconds of green light, yellow light for 15 seconds and then red light is going to come. So I have to stop my vehicle. I should stop moving. Okay, there is nothing automated to see that whether any other person is going, it will not stop. The light will change according to the time. So the desired time is set, then power is given to the relays, to the control sequence, then the lights will be put on or off. This is how the open loop control systems work. Now coming to advantages of an open loop control system. Such systems are simple in construction. Okay. Then very much convenient when output is difficult to measure. See, all the time it is not possible to measure the output, isn't it? So in that case, open loop control system is preferred. They are easy from maintenance point of view. Generally, these are not troubled with the problems of stability. Systems are simple to design and economical. But the disadvantages are inaccurate and unreliable. Then they cannot sense internal disturbances in the system. Then to maintain the quality and accuracy, recalibration of the controller is necessary again and again. Time and again, recalibration is necessary. That is how open loop control system has advantages and disadvantages in the control system. Okay. So now coming to the most important type of control system, that is the closed loop control system. So listen carefully. A system in which the controlling action or the input is somehow dependent on the output or changes in output is called a closed loop control system. To have dependence of input on the output, such system uses the property of feedback. Very important. Okay. So then what is feedback? Feedback is the property of the system by which it permits the output to be compared with the reference input to generate error signal based on which appropriate controlling action can be decided. Okay. In such system, output or part of output is fed back to the input for comparison with the reference input applied to it. So now see the block diagram of a closed loop control system. Okay. So first we will start from left to right. There is the command input. Command input is one routine regular input. Okay. Then that is converted into reference input with the help of a reference transducer. What is this reference transducer is? The system, control system will accept only some form of input. All inputs it doesn't accept. So the command input is the actual input that is converted into the reference input and fed to the control system. Then there is one error detector, or this is called as the summing point, the error detector. R of t is the reference input. It is given to the comparator error detector. Then there is the controller, which is the main controlling element of the control system. That is the controller. From the controller, the signal goes to the process to be controlled, the plant or the process or the system to be controlled. And from there we get the output. It is called as controlled output because every time we are controlling it. So this output C of t is measured and fed back with the help of feedback element. With the help of feedback element, it is fed to this comparator or error detector. So here that signal is B of t. So B of t and R of t are compared and the error generated E of t is fed to the controller. Then the controller uses this error to generate a signal, manipulated signal called M of t, which is given to the process to be controlled and which gives the output. That means this cycle repeats every time. So here the various signals are R of t, reference input, E of t, error signal, C of t, controlled output, M of t, manipulated signal, B of t, feedback signal. So this feedback comes into picture here. What happens in closed loop control system? The output C of t is measured. Then it is fed back to the comparator or error detector here. The error detector or comparator is also receiving the reference input signal. Both are compared. If there is any lacuna, if there is any problem, an error is generated. That error signal E of t is fed to the controller. The controller, which has all the control in its hand, changes the signal in the form of the manipulated signal, gives it to the processor plant to be controlled, and we get the output. The output is going on improving every time. The output will go on improving every time. Okay. So then what are the advantages of closed loop control system? Obviously, when we are comparing the output, measuring it, then feeding it back, generating the error, improving the controller output, accuracy of the system will always be high. Okay, because the controller every time modifies and manipulates the actuating signal such that the error tends to become 0. These systems sense environmental changes as well as internal disturbances accordingly. Then in such systems there is reduced effect of non-linearities and distortions. Okay. Then bandwidth of such system, that is operating frequency zone of the systems, is very high. What are the disadvantages then? Obviously, complicated and time consuming from point of design and therefore costly also. So see the disadvantage. Systems are complicated, time consuming to design and also expensive systems. Due to feedback, the system tries to correct the error from time to time. Tendency to overcorrect the error may cause oscillations without bound in the system. Hence, the system has to be designed taking into consideration problems of instability due to feedback. So what is this? What this second point means is, see, every time output is measured, it is compared, then an error signal is generated. That error signal is given to the controller. The controller changes its signal. So this repetition of process may lead to overcorrection also, which is not necessary sometimes. Okay. Every time we don't require a 100% perfect system. Sometimes some inaccuracy is accepted. But this overcorrecting may cause oscillations in the system, thus affecting the stability of the control system, which is one of the most important requirements of a control system. Stable. The control system has to work stably. Okay, without any oscillations, without any fluctuations. But in a closed loop control system, to maintain that stability is not so easy. It becomes difficult to maintain the stability of the control system. But still, closed loop control systems, even though complicated and time consuming and costlier, they are the preferred systems because they have the highest accuracy and they are very, very good systems. They are preferred everywhere, and the modern control systems, the sophisticated control systems, most of them are closed loop control systems. Now coming to the real-time applications. In the previous class also I have told, human being is the most complicated closed loop control system in the nature. Okay, human being. For example, if a person wants to reach for a book on the table, one book is kept on the table and the person wants to reach the book on the table. See how it works. Position of the book is given as reference. Okay. Position of the book is given as reference. Feedback signal from the eyes compares the actual position of the hands with the reference position. Error signal is given to the brain. The brain manipulates this error and gives signal to the hands. This process continues till the position of the hand get achieved appropriately and the hand is able to touch the book and picks up the book. Okay. See here, this is the block diagram representation. Reference position of the book is the input. Then eyes, that is feedback from the eyes, is the feedback. That is compared, error is generated. That error is given to the brain, which is the controller here. See, what is the controller? Brain is the controller. So it gives signal to the hand whether to push the hands further or to pull them back, to adjust so that you will reach the book on the table and it is picked by the hands. This is the perfect example in nature of the human being picking up a book from a table, where it works perfectly as a closed loop control system. Okay. Then coming to the home heating system, which I have dealt again and again. So this also can be made a closed loop control system. So last time I have talked the same system with open loop control. This can be converted into closed loop control system also, because when the house temperature, when you get the house temperature, if you have some sensors to measure that temperature and compare it with desired temperature. Suppose desired temperature is 27 degree and the house temperature is not 27 degree but 26 degree. So ಅಕ್ಕಿ ಏನು ನನ್ ಬೇಕಾಗಿಲ್ಲ. ಏನ್ ಚಂದ ಐತ್ಲೇ ಸಮಯ ಇದು. ಆದ್ರೆ ವಾಪಸ್ ಕೊಡ ನಮ್ಮ ಪಪ್ಪ.